How many people have seen one of those before? A polynomial function. Oh, come on. You're in calculus. You've seen it before. I'll ask again. How many people have seen a polynomial function before? I'm going to ask one more time. How many people have seen a, there we go. Have you seen a function before?
Yes.
Yeah. About 99% of the functions you have seen, like a huge percentage of the functions you have seen, have been polynomial functions. A huge percentage of them have been polynomial functions. So, could someone just give me a polynomial function? Like, list one for me.
5x squared minus 3x.
Yeah, so how about f of x is 5x squared minus what?
3x.
Sure, that's a polynomial function. Can someone tell me why it's a polynomial function? There's really only two things, yeah.
There's like 2 terms. There's more than 1 term.
Can a polynomial have one term?
Yeah.
Ah, multiple. That's a really good point. It does say polynomial. Technically speaking, polynomials can have one term. You just call them a monomial, but they are like, of all polynomials, you can have monomials, right? So how many terms can a polynomial have? How many do you think it can have? It could have, they're actually infinite term polynomials, absolutely. Yeah. Do we look at those in this class? No. So, okay, we have terms. What about the terms make it a polynomial? You know this, you can figure it out.
Degree.
They what?
Degree.
The degree. So there's something about the degree. What's the degree of this polynomial right here? This is a second degree polynomial. Why is it a second degree polynomial?
It goes up to 2.
The highest power, exactly, the highest power represented is 2. So you see this. Now, it's written in descending order. What's the power right here?
1.
Exactly. So there's a proper form. All the like terms are brought together. So the degree of this polynomial is 2. But what's the limit on the degrees? There's something about the degrees. What can the degrees not be?
0.
If they're the same, then we combine them. Exactly. So if they weren't, it wouldn't be written in proper form. You're right. Absolutely. What the numbers? Yeah. They have to be whole numbers, right? There's actually another term here. It would just be like x to the 0. What is x to the 0?
1.
Oh wait, we can't do that, can we? All right. So it isn't there. So I can't say that, can I? Maybe I could do this, right?
0x.
0x to the 0, right? There's 0 of them, right? There's no constant term. If I wrote this instead? Let's say I wrote 7x to the 0. What does that equal?
7.
That's 7. So that would be the fancy way of writing 7 in descending power. Exactly. So what about the powers? They have to be whole numbers or 0, right? They have to be whole numbers or 0. Nice. So they can't be negative. They also can't be what? Fractions. Exactly. So if you saw, y is equal to x to the 3/2, is that a polynomial? That is not a polynomial. That is not a polynomial. You also can't have negative numbers, right? Or irrational numbers. That's nice. What about the coefficients? What can the coefficients be? It doesn't say it on the sheet, but what can the coefficients be? They have to be what? They can actually be, can they be fractions?
Yes.
Yeah, they can. So you could have, I don't know, you could have, let's say, f of x is equal to negative 5/2 x cubed minus the square root of 2x. Is that a polynomial? It is. It's a polynomial. Are the powers whole numbers? What are the 2 powers in there? 3 and 1, right. What are the coefficients? Negative 5/2 and negative root 2. That is a polynomial, right? So there's 2 types of numbers. Most of the numbers that you deal with, almost all of the time, are this type of numbers. Anybody know what they're called? Yeah.
Real?
Yeah. Where do real numbers exist? Any number that exists on the real number line is a real number. If a number has a home on that line, it's a real number. It's a real number. The question I have is, what's the other set of those numbers?
Imaginary.
Imaginary numbers, right. Does anybody remember what the big set is called? There's a big set of numbers, and this half of them are the real numbers, and this half is that's imaginary, right? Anybody know what that whole set is called? Anybody know? No bonus question? Begins with C. I'll write it slowly. C-O-M. The complex numbers. A plus BI. Does that ring a bell? A little bit, right? So if there's no BI term, it's a real number. So anything that's a real number can be a coefficient. Now, what happens when you make the coefficients really, really weird? well, they can be sometimes nasty to deal with. So luckily for you, do our coefficients stay a little bit nice? They stay a little bit nice. Excellent. So if I had to ask you what a polynomial, you would say it's a collection of terms. The powers of x are all what? Whole numbers, and the coefficients are real. That's the two things, exactly. So a rational function, how many people have seen that term before? Has anybody seen rational function before? A little bit maybe? Probably spent some time in pre-calculus dealing with them. You like them a lot, they're really exciting. Exciting, isn't it? If you ever get lost, if you're not sure what a rational function is, what are the first 5 letters of rational? Ratio. And what is a rational function? It's a ratio of? Of what? To what functions? Polynomial functions. So a rational function is just a ratio, a fraction, where the numerator and denominator are both what? Polynomials. Yeah, exactly. Exactly. You've seen them your entire math life, pretty much. Entire math life. Because what numbers are fractions? All of them. All the numbers are fractions. Because what can you put any number over?
1.
Right. Yeah. So 6 over 1 is what? A fraction. Nice. It's a fraction. Exciting, right? Is that a polynomial? 6 over 1? Is 6 a polynomial? Sure. That is, make it a polynomial? Yeah. So have you really seen polynomials your entire life? It's really key. It happens in math a lot where you actually see the big rule, but you really only look at pieces of it. And then you get to a certain point in math and you're like, oh, there's this big rule that's out there. Here's one of them. Okay, so let's look at rational functions. And you might have seen things like this before. I think you have. How many people have heard of the word asymptote before? Asymptote. Asymptote. So here's the first quiz question. Write it down right now in your notes. Write down the word asymptote. Just write it down. Can you spell it again? It's A, then what?
S-I.
S-I. Oh, you said I?
Y.
S-Y, yep.
M.
Yep.
P.
Yep.
T. O-T-E.
Nice. Asymptote. Asymptote. So, we're going to see lots of asymptotes. We're going to see them. And before I describe exactly what they are, let's talk about the pieces of terminology that go into understanding what they are. How many people have heard that word before at least heard it? Nice. Okay. So what we'll do is we'll look at this question right here. So it says, draw a function given the following conditions. So the first thing you have to do is understand what those conditions are. So can someone read out loud to me what that first thing says? What does this say out loud? Can anybody take a stab at reading that out loud to me? Can anybody read that out loud to me? Danny.
F of x as x approaches 0 from the right side equals infinity.
Ah, equals. So the thing is, that is about 95% correct. And I like how you started with f of x. I like that, Danny. I like that. It's fantastic. So what does limit mean? What do we mean by limit?
Reaches.
Do we ever get to it? Yeah, well, actually, sometimes you do. Can you cross asymptote? You can. Not all the time, but you can. You can. But generally speaking, when you say a limit, you're getting closer to it. So if I got halfway to the wall, and halfway to the wall, and halfway to the wall, and halfway to the wall, if I have a finite amount of time, I would never reach it. What's the limit? The wall is the limit. The wall is as far as I can get arbitrarily close to the wall. So what this is saying is f of x gets arbitrarily close to what? Infinity. So what does that mean when arbitrarily close to infinity? Is infinity a number?
No.
No, it's a what?
Concept.
It's a concept, exactly, right. So if a function is getting arbitrarily close to infinity, what does that mean?
There's no limit.
Be more specific.
There's no maximum.
There's no what? There's no maximum. So what happens to the f of x function as x goes to 0 from the right? It increases forever. It increases forever. So let's go back and let's go over here. Where does this function, where does x equal 0 on this function? What's another name for x equals 0?
Origin.
Not the origin.
X.
Nope. Where does x equal 0? The y-axis. So this right here is the y-axis. This is where x is equal to 0. And what was that key thing that Danny said? It was really good that Danny said it. He noticed the plus sign. What does that mean? From the right side. So from the right side, what happens to this coming in from the right? The function does what? It goes what? Up or down? It goes up. It spikes upward. It goes infinitely up. It goes up. So let's look at the next one. Can someone read this one out loud? Can someone else read that one out loud? It approaches x from the left. So if you're marching along, as x gets to 0 from the left, what does the function do? Spikes down. As it comes from the right, it spikes up. Do we know anything about the rest of the function at this point? No. This question is just asking, draw a function that models this behavior. So let's look at the rest. Oh, the limit as x goes to infinity, it approaches 2 from the what? 2 from the right. As x gets infinitely big, this function approaches 2 from the right side. So how would you graph the line y equals 2? I'll use green on this one. So if y equals 2 on this one, what kind of line is y equals 2? It's a horizontal line. Thank you. So here's our horizontal line right here. Y equals 2. So as x gets infinitely big, what does the function do? It gets infinitely close to 2. So we'll end up with that. What does the next one say? What's the only difference here? As x tends to what? As x goes to what? Negative infinity. What does the function approach? 2 from the... And it's interesting. Since it's the output, it's going to be 2 from the bottom. 2 from the bottom. Because this is an output value, right? This is an output value. Output values are y values. So this means 2 from the bottom. 2 from the bottom. 2 from the bottom. So what is it going to look like? Let's look at the big picture here. What's it going to do? It's going to do that. This is not negative 2. This is 2 from the bottom. 2 from the bottom. Someone read out what that's asking. It's what? What's going on for A? What's it asking? Yeah.
The limit of f of x as x approaches infinity.
Yeah, so what happens as x goes to infinity? So as x goes infinitely to the right, what happens? What does it approach? 1 from the what?
Positive side.
1 from the positive side. Exactly, right. What about x going to negative infinity? 1 from the bottom. Exactly. Now take a minute, everybody. From the left, here's negative 2. So what happens when you approach negative 2 from the left? Where's the function going? It's going up or down? It's going down. So what's this going to be? Negative infinity. Exactly. Right, I'm going to change colors again here. Excellent. I'm going to go blue here. Negative 2 from the right. What's that going to be, Mikey? Up. So what's that going to be? Yeah, and the one thing that's a little... I like the arrows on these. I should put arrows on these. Is that better? Does that make you feel better? Exactly. Nice. Okay. Who wants to tell me the next two? And I'm going to see if I can get some... Oh, let's go back to green here. 3 from the left. That's 3 from the left. So as x approaches 3 from the left... Who wants to answer that one? Liv. 3 from the left. Yeah, it goes down. Exactly. Negative infinity. Yep. And what about 3 from the right? Yep. You can say it's really fine putting a positive. It's totally fine. That is emphatic. That tells me you're not unsure. That's fantastic. Are there any questions on these right here? Any questions? Specifically though, when the denominator, what numbers make the denominator 0? That's what you ask here. What numbers make the denominator equal 0? And what's the only number that makes the denominator equal 0? X, so this is going to be x equals 3 is the vertical asymptote. Fantastic. State end behaviors. The end behaviors are what happens when x gets infinitely big or infinitely positive and big or infinitely negative and big. So it's, for B, it's the limit as x goes to infinity of f of x. And what's the other one?
Negative.
Exactly. Negative infinity of f of x. So what you do is you think to yourself, when you plug in a huge number, a trillion bajillion plus 4 over a trillion bajillion minus 3, do the plus 4 and minus 3's do much? No. So what does it get really close to? 1. And so does this one right here. They both do. Because what's negative a billion plus 4 over negative a billion minus 3? 1. How do you figure out, though, what side it is? Is it coming from the top or the bottom? Top or bottom. So is it going to be above 1, or is it going to be greater than 1 or less than 1? That's what you have to figure out. So let's look at the top one first. A billion plus 4 over a billion minus 3. Which, technically speaking, is the top going to be bigger or the bottom going to be bigger? The top is bigger. So if the top is positive and bigger than the bottom, which is positive, is it greater than 1 or less than 1? It's greater than 1. So the top one is going to be 1 plus, because this is like a little bit bigger than a billion, and the other one's a little bit smaller than a billion. What about the bottom one, though? You have to be careful, because when you're going to negative infinity, you're going to have negative a billion, I love writing that out, plus 4 over negative a billion what? Minus 3. So that could be, if you did bigger, you have negative 10. Oh man, what is it? It's really close to 1, right? But is it smaller than 1 or bigger than 1? What do you think? Tricky. What's the one on top? Negative what? 999,996. Negative over so what's this going to be? One from the bottom, because it's this thing right here is less than 1. Here's a pro tip. When in doubt, literally just plug in a number. I'm going to give you limits. We're going to have all these crazy things to do, but sometimes, you know how you can find the answer? Just plug in a number. Like pick one, and you can figure it out. Yeah, standing.
I know the answer.
Last thing here. All intercepts here. Intercepts. Exciting, exciting, exciting. Yeah, x-intercepts are when what is true? Y equals 0. And y-intercepts are when x is 0. So how do you literally find the intercepts? Plug in those numbers, right? So which one's generally easier to find, the x-intercepts or the y-intercepts? I think the y-intercepts are easier. So you plug in y. In this case, it's not that bad, either one, right? So in this case, what is the y-intercept? You plug in 0 and you end up with what? Negative 4/3, I think. You see how it's a point? I like a point being the intercept. And the x-intercept is when y is 0. So you have to solve this. 0 is equal to x plus 4 over x minus 3. When does that occur? So I like writing it as negative 4 comma 0. Fantastic.